Hello friends, in this video I'd like to solve the following problem from the Thailand Mathematical Olympiad 2020, problem number 7. We wish to find all functions going from the set of real numbers into the set of integers, it's very important, such that f of x squared plus f of y squared is less than or equal to 2 times f of x times y for all real numbers x and y. So my hints for this problem: first, try setting some obvious values like x and y equals 0. Then it might be helpful to think about the following two possibilities. What happens if f attains the value of 0? And furthermore, think about, can f attain negative values for some arguments? So give this problem a try and I will see you in a minute. Okay, so as I suggested, maybe let's first answer the last question. Notice that by setting y to be 1, we get the following. F of x squared plus f of 1 squared is less than 2 times f of x. And obviously, the left-hand side is non-negative. This is obviously non-negative, which means that f of x must also be non-negative for every real number x. So in other words, function f cannot attain any negative value. Okay, now let's try setting x and y to be 0. So set x and y to be 0. What happens now? Well, now we have the following. F of 0 squared, 2 times in fact, is less than 2 times f of 0. And let's put everything on one side and do a little bit of factorization, and we get the following. And remember that our function attains only integral values. Only integers are in the range of our function, which means that this inequality can be true only in two cases, namely when f of 0 is 0 or when f of 0 is 1, because in other cases we will have either the product of two positive numbers, two positive integers, or the product of two negative integers. So we now know that, maybe I'll write it in green or in yellow, why not? That means that f of 0 is 0 or f of 0 is 1. Let's investigate these two possibilities separately. Case number 1. Case number 1. When f of 0 is in fact equal to 0, then we will set the following. We will set just y to be 0. And we have now f of x squared plus f of 0 squared less than 2 times f of 0. Which means that f of x squared is less than or equal 0, which means that our function must be constantly equal to 0. Because square cannot be negative in real numbers. And it's pretty obvious that this function satisfies our functional equation. So let's write it. This function obviously satisfies our condition, our inequality to be exact. Okay, so let's now consider case number 2, when f of 0 equals 1. Well, let's also set y to be 0. And this time we can derive the following. F of x squared plus f of 0 squared is less than or equal 2 times f of 0, which means this is 1, this is 2, so we have f of x squared is less than or equal 1, which means that for every real number x, f of x is either 1 or f of x is 0 or 1. It cannot be minus 1 because of the first part of our reasoning. We have established that our function attains only non-negative values. So our function can attain only the values of 0 and 1. And now I need another page. Okay. And now let's consider the possibility. What happens if our function attains value of 0 for some x? So what happens if f of x sub 0 equals 0 for some real maybe not x sub 0, maybe write y sub 0 for some real number y sub 0? Well, then what? Then let's set the following. Set y to be y0 over x, and let x be non-zero. And we get the following. F of x squared plus f of y sub 0 over x squared is less than 2 times x times y, it's just y sub 0. And that, by our assumption, that is 0. And look, here we have sum of two squares, which is less than or equal to 0. That can only happen if f of x is 0 itself. X was arbitrary but non-zero. So for every x which is not 0, f of x equals 0. Okay, so now we know something. So what? So we have the following possibilities. That implies that either f of x is 0 for x non-zero and 1 for x which is 0, and in other case, if there is non-number, there is or if f doesn't attain value of 0, then it must be constantly 1. Well, okay. The second function, namely this one, function which is constantly 1, obviously satisfies our condition. Obviously satisfies our condition. So we have to do one last step, namely we have to verify if this function, which is 0 for non-zero x's and 1 for x equals 0, if this function satisfies our condition. So we will check if f of x, which is 0, 1 for x non-zero, and second function which is 1 for x 0, if this function satisfies our functional inequality. Well, recall that our inequality was f of x squared plus f of y squared less than or equal 2 times f of x times y. And now let's notice the following, that if x, so maybe let's put what exactly? So let's put if x is non-zero and y is non-zero, then on the left hand side we will have just 0, and right hand side will be 0 as well, so our inequality holds. So let's try what happens if both x and y are 0. If both x and y are 0, then the left hand side will be 1 plus 1, which is 2, and the right hand side will be 2 as well, because product of 0 times 0 is 0, and f of 0 is 1. And finally, if x is 0 and y is not 0, then left hand side will be f of 0 squared, which is 1. 1 plus 0 is 1, and on the right hand side we get 2 times f of 0. F of 0 is 1, so it's 2. We see that in either case, in any of the three cases, our inequality is fulfilled, because 0 is less than or equal 0, and so on. So all in all, our functional equation has 3 solutions. Our functional inequality, to be exact, inequality has 3 solutions. Either f of x equals 0 for every x, that is one possibility, or f of x is constantly 1 for every x, that is second possibility, or the third and final function, f of x can be 0 for x non-zero and 1 for x equals 0. That function also satisfies our condition. Okay, so thank you for watching. I hope that you've learned something new. I hope that you were entertained by my reasoning, by my talking, by doing mathematics. And I will see you next time. Goodbye.